So here's the schematic of our superluminescent light projection system. In the right side of the figure, we have used the commercially available superluminescent light diode as a light source of the SLP system. The light is focused into the 2D light sheet at the focal plane of the lens using the oil immersion lens. By using the high numerical aperture lens, more indirect light is collected and it generates higher resolution of printing. We have adapted an upside-down project system wherein the light first passes through the oil immersion medium and then through the glass substrate before it focuses into the metal ink solution. Due to the low cost of the SLED compared to the femtosecond laser used for the 2-photon reduction, we can reduce the cost of the printing about 100 times cheaper than the 2-photon reduction process. So thereby our low-cost optical system can generate the finely focused light spot that is in some micron level. And the main approach, the reason why we use the superluminescent light diode is explained in this slide. So it's mainly because the distinctive light property of itself compared to the other light sources in the market. This is the work from the other group, the study of the light coherence of the different light sources with the laser and the SLED and the LED. As is shown in this slide, the different light sources tend to have the different light spatial and temporal coherence. For example, the laser diode on the left side of the column is temporal coherence, and this generates the large speckle effect. And this can result in the undesirable background noise during the printing process. On the other hand, the LED used for the digital light projection system is spatially incoherent and thus generate the less sharp image, even if it has a less speckle effect due to the temporal incoherence. As a result, we use the SLED, which is the spatially coherent and temporally incoherent. Therefore, we can get sharp edge image with the less speckle effect. By doing so, SLED can focus the light to a sub-micron scale, while DLP can only project the micrometer scale images. And here's the actual setup of the SLP system in our STEAM lab at Georgia Tech. And we use the superluminescent light diode, which is 10 times smaller and 100 times cheaper than the ultra-fast laser. On the right side of the figure, here's the schematic of the processing flow of the SLP. We use the bitmap image where the white region and the black region works as an on and off pixel for the digital micrometer device. Once the digital pattern is projected, the pattern is then demagnified through our optical setup and projected at the interface between the metal ink and the glass substrate. This pattern is projected within a few seconds of exposure time, and after development processing in IP and DI water, we can observe the nanoscale 2D metal structure fabricated by low intensity light under the single photon absorption mechanism.